All right, so here I'll be going over the Inverting Op Amp Configuration. So the first thing we can do is draw the op amp real quick. So we'll have ground, and we will have our voltage source connected to the inverting input of our op amp, as well as the non-inverting connected to ground. We will have a resistor here. We'll name this Vn, and we're going to have a negative feedback going through a resistor connected to our output. So this is what a general inverting op amp configuration will look like. And we'll call this Rn, Rf, Ri, and Rf. Beginning with, there are a few things we want to take note of, and these are going to be the ideal characteristics of the inverting op amp, an ideal inverting op amp. Beginning with our Rin, we want to have infinite impedance, which means no current I will flow in here, right here. And it's going to create a virtual short between these two nodes, between the inverting and non-inverting input of 0 volts, a virtual short, and our output resistance is, we want it to have 0 impedance, with an open loop gain A, infinite, close to infinity. Of course, we cannot get infinite in real applications, real world, but this is ideal. So because of these ideal characteristics, we're able to make some other generalizations, and that's going to be the current that's coming, that's flowing here and over our feedback is going to be the same. So I'll give it a classification. We'll call it I1, and we'll call this one I2. And now we can equate these. I1 is equal to I2. Awesome. So now we can derive the equation for the output and the gain, or closed loop gain, G, is going to equal our voltage out over our V in. So by solving for V out in terms of V in on the other side, we can end up with this equation. So exactly what we're going to do. So to make this look easier, I'm going to redraw the top of this circuit, but usually you should be able to, and you'll want to be able to see it. So redrawing the top of that circuit here, we're going to have our ground, our voltage source, resistor, in, node, up, over, other resistor, out to our the out. I had to go up here. You could have just gone straight. Awesome. So this is what the top of that op amp looked like. I have a node there. And now we can do this in terms with our current, the current going through it. So we have a current going here. Do it in terms of this direction, they're still equal to each other. We know that, and because of what we have up here, we also know that the voltage at this point, so at this point here, is going to be equal to the voltage at this point here. And we know what the voltage is, this is ground. We know with that virtual short, it's going to equal 0 volts. So if we call this VB, and we call this one VA, VA equals VB, which equals 0 volts. And that'll really help us out here. So coming back down here, we know that this point VA equals 0 volts. So let's write our equations to solve this here, because we have our current here and our current here. We're going to do two equations, and we're going to have our Vin minus VA. So here, over this resistor, Ri is going to equal I1. So like for current, we have voltage over resistance. And then we have VA minus Vout over RF equals I2. Using what we've already written before, we know that I1 equals I2, so we can equate these equations. We can have Vin minus VA over Ri equals VA minus Vout over RF. So let's solve for Vout. What we can do is, one thing we know is that VA is 0, and that equals 0. So we can rewrite this one more time. Vin over Ri equals negative Vout over RF. Multiply RF over, or we can do -1 over RF multiplied over. So that's going to give us Vin times negative Ri over RF equals Vout. And that is solving for Vout. So I'll rewrite it this way. Vout equals Vin times negative Ri over RF. You could rewrite that in many, you could write that in many different ways. You could do negative Vn times Ri over RF, negative Vn Ri over RF, all the same. And now, if you remember our closed loop gain, G equals Vout over Vn, in our case, Vo, V naught over here. So we can just divide Vn over. So Vf over Vn equals negative Rf over Rin. Therefore, we have found our closed loop gain and our